Hello, everyone, and welcome to another episode of Kelly Telly. I'm not sure if it is going to come out in the video compression or not, but I was having a little bit of audio difficulties. I'm not sure if I sound robotic or not. Hopefully, I don't, but nevertheless, I think it was still hearable, so I'm going to push on. So today we're going to be talking about the particle theory. Now, this is going to be the first bit of new content we're covering this term. So let's jump straight into it. So, what is the particle theory? Well, just basically, we're going to start with the definition. So, the particle theory states that all matter consists of many very small particles which are constantly moving or in a continual state of motion. So, the important things to take away from this is that everything in the world that is made up of matter, which we learnt last term is anything that has mass and takes up space, consists of many very small particles. Now, if you were to have to provide a name for those particles, they would be atoms. Now, as I wrote here, these particles do not need to be defined, but we do know them as atoms. But for the remainder, when we're talking about the particle theory, I may use atoms and particles interchangeably. So it's just the way physicists think is they don't always think of things in terms of atoms. They just like to refer to them as particles. So we may do the same thing. So just be aware of that. Now, so all of these particles that make up all matter are in a continual state of motion. So they're either constantly moving or in a continual state of motion. So that's important. So here's a little diagram. So all these particles here, they're always moving. Now there is a difference between the different states that the particles are in. And we're going to call those the different states of matter. So the different states of matter. Let's have a look here. So um, we're looking at here three of the states of matter. We have gas, liquid, and solid. So you can have a gas, liquid, and solid of any chemical that exists on Earth. Any chemical at all has a gaseous state, a liquid state, and a solid state. So it all has to do with how the particles, right, are arranged. And this is what we're going to do when we talk about the different states of matter. So if you have a look, these are just little examples of how the particles are arranged for this example substance. So let's just say this is oxygen, for example. Two oxygen atoms or two oxygen particles. Um, when they're in a gaseous form, they are spread away as far as possible and moving constantly around. So the oxygen that's in the air that we know, it's all moving around us. Now in a liquid form, the particles are a little bit closer together. They actually flow over one another. Excuse me. So they do connect. Um, they do touch each other and move about, but they are not as compressed as they could be. They are at their most compression when they are a solid. So when they're a solid, all the particles are touching and they're all arranged in a certain way. So these are states of matter. Just got some information here. So there are three states of matter found commonly on Earth. There's solids, liquids, and gases. Now, although I haven't got a diagram of it here because it's not that crucial that we know, there is a fourth state of matter, and that's called plasma. It's most commonly found in space, in the core of stars. That's where you'd find that one. So um, these ones are the ones I want to look at, and these ones are going to help us understand the particle model most effectively. So let's have a look here. Looking at a comparison of solids, liquids, and gases. So let's just start with a solid. So in a solid, the arrangement of the particles. So the particles are all very close together and they're in a regular pattern. So remember when we were looking at the ionic structure of sodium chloride, for example, it was in a very kind of clear, arranged way that the particles so would go sodium, chloride, sodium, and so on. In a very regular pattern. And that's very common for solids because the main way they stay stable is when they form those different arrangements. Now, we'll come back to the movement later, we'll just stay on the arrangement. So in a liquid, the particles they're close together, but they're in a random arrangement. So they're not as structured and rigid as in the solid. They're actually in a kind of in a way in which they can kind of move around each other or flow over each other, is what we say. In gases, they are far apart, so they're nowhere near each other if they can avoid it, and again, it is random as well. So they will move to any one particle can move to any one direction. I'm actually going to show you a simulation probably tomorrow when we talk about heat and temperature that will hopefully make it a little bit easier to understand the states of matter and the particle theory. But for now, we're just going to push on with this. Let's look at the movement of the particles. So in a gas, the particles move quickly, so they're moving much faster than liquid and solid. They're moving as fast as they can. In liquid, they are moving, but they're not moving as fast, and they're not spreading around as fast. Finally, in solids, you would probably say, the desk you're probably sitting at right now, and looking at the desk, that the solid, obviously that's not moving. Well, it actually is. The small particles that make up the desk, the atoms, do actually vibrate at a speed that we don't really detect, but they are moving. It's just very difficult to detect. So everything in the world that is made up of matter is always moving. Okay, and that's what the particle theory tells us. So the particles in a substance change arrangement based on the amount of energy. So this is something that we're going to touch on probably definitely in later topics. But basically, that the particles in a substance, they change arrangement based on what it is actually on the amount of energy provided to that substance. And if you have a look um, at all the different topics we're doing this term, they all talk about a different form of energy. And this is why we need to have a good understanding of the particle model. So just to kind of recap here, the particle model talks to us about the arrangement of the particles or atoms that make up all matter that we have on Earth. And the other thing that it tells us is that they are all constantly moving. They are all moving to different degrees. So gases obviously move very quickly, liquids move less so, and solids don't move much. They actually just vibrate on the spot. And in gases, the particles are far apart, and liquids and solids, they're close together. In the liquid, they're in more of a random arrangement, and in a solid, they are closer together than a liquid, even though it doesn't say that here. It's closer together, and also have a regular pattern there. So I hope you understood this introductory video to the particle model. If you have any questions, please comment them below or contact me on Edmodo to ask them. I think that about does it.